In this module, I'm going to be covering the topic of acids and bases. One of the most important things you need to do when you're dealing with acids and bases is to be able to identify the difference between an acid and a base. So going through this, we think of an acid and a base and the difference between them. And I want to note that I will be discussing the Bronsted-Lowry definition of acids and bases. There are some other definitions of acids and bases like Lewis acids and Lewis bases, but in this course and in this module, I'm going to be dealing with the most common acid and base definition, which is the Bronsted-Lowry. So very simply, an acid is something that wants to donate a hydrogen. A base is something that wants to accept a hydrogen. So the best way to go through this is with an example. So if we think of an acid, there are tons of types of acids, and I'm going to go through that in future videos, talking about how to identify the different types of acids. But one acid we can think of is HCl. So usually you will see acids written out like this to show the hydrogen that is going to donate. So then we can think of a base. One example of a really good base is hydroxide, which is OH, and remembering formal charge here, oxygen has 3 lone pairs, so it has a minus charge. So what happens during this acid-base reaction? So what will we see when an acid reacts with a base? Well, exactly what we said before. The acid wants to donate the hydrogen, and the base wants to accept it. So a base works by using its lone pair to take this hydrogen away from the acid. We then see this bond that is made up of electrons. We see this bond go to the chlorine. So what are we left with after this acid-base reaction? Well, oxygen now has 2 hydrogens, and instead of having 3 lone pairs, we only have 2 because we just used one to accept that hydrogen from the acid. Now, the chlorine originally had 3 lone pairs, but now this bond of electrons is now on the chlorine. So we can see chlorine with 8 electrons. It wants 7, so it will now have a minus charge. Often you'll see acids, when they give away their hydrogen, have a minus charge. That is because that pair of electrons is now sitting on that atom as a lone pair. So just to summarize, an acid wants to donate a hydrogen and a base wants to accept a hydrogen. And in the next upcoming videos, I'm going to be going more in depth on how we can see acid and base reactions, and also see how equilibrium will apply to our acid-base reactions and calculate how much of an acid we have and how much of a base we have left after a given time and a reaction goes by.